Imagine a cosmic traveler from beyond our solar system, shrouded in a mysterious fog of carbon dioxide. This is not just a figment of imagination. It's the reality surrounding the Interstellar Comet known as 3I Atlas, recently unveiled by NASA's Advanced Space Telescope. On July 1st, 2025, the Deep Random Survey Telescope, located in Chile and part of the Atlas Asteroid Terrestrial Impact Last Alert System initiative, made a groundbreaking discovery, a new comet that is unlike any other. This comet is not bound by the sun's gravitational pull, indicating that it has journeyed from a distant star system far beyond our own. Designated as 3I Atlas, this remarkable comet is only the third interstellar object identified to have entered our solar system, and it stands out as the largest and brightest among them. It's no wonder that astronomers worldwide are focusing their instruments on this celestial wonder, including NASA's newly launched space observatory, SPHEREx. SPHEREx, which stands for Spectrophotometer for the History of the Universe, Epoch of Reionization and ISIS Explorer, has made a significant discovery. It has detected a substantial amount of carbon dioxide gas enveloping the comet's fuzzy coma, along with water ice present in its nucleus. This finding is pivotal for scientists as it enhances our understanding of how comets from other star systems compare to those formed within our own solar neighborhood. Interestingly, the characteristics of 3I Atlas suggest a notable similarity to our solar system's comets. The detection of large quantities of vaporized carbon dioxide around 3I Atlas indicates that it may behave like a typical comet found in our solar system, explained Carey Liss, an astronomer from Johns Hopkins University and a member of the SPHEREx science team, in an interview with Space.com. Comets are fascinating celestial bodies composed of rocky dust, water, carbon dioxide and carbon monoxide, the three most prevalent icy components in our solar system. The specific amounts of these substances depend on the conditions under which the comet was formed and how it has evolved over time. Lissay elaborated, stating that these ingredients sublimate, or evaporate, into space at varying temperatures. For instance, a comet that originated at the farthest edges of our nascent solar system and was subsequently ejected into the distant Oort cloud would typically contain abundant amounts of all three ices. In contrast, a comet that formed closer to the Sun or remained in proximity for an extended period would likely lose its carbon monoxide, retaining primarily water and carbon dioxide. The observations made by SPHEREx reveal that the carbon dioxide coma surrounding 3I Atlas, especially one that lacks carbon monoxide, along with its water ice nucleus, suggests that this comet underwent significant thermal processing before being expelled from its original solar system. Liss remarked, 3I Atlas is acting like a typical, well-processed cometary object found in our solar system. However, Liss speculates that this comet likely hails from a much more distant region within the thick disk of the Milky Way galaxy, making it potentially 2 to 3 times older than any comet discovered in our solar system. The recent analysis of 3I Atlas's composition showcases the exceptional capabilities of the SPHEREx mission. Liss noted, SPHEREx excels at creating 102 different wavelength maps of the entire sky, spanning deep red to mid-infrared wavelengths from 0.75 to 5.0 microns. Many of these wavelengths are challenging to study from Earth due to atmospheric interference, providing cometary scientists with unprecedented access to crucial chemical signatures in their research. Olivier Doré, the SPHEREx project scientist at NASA's Jet Propulsion Laboratory in Southern California, highlighted the broader implications of this mission. By mapping the entire sky in 102 colors, we can investigate a wide array of celestial objects, from distant galaxies to nearby stars in the Milky Way, as well as comets in our solar system, whether they are interstellar visitors or not, he stated. This truly emphasizes the transformative potential of the dataset we are generating. The richness of the data is extraordinary and will undoubtedly lead to discoveries across the astronomical community as we continuously release our findings. As SPHEREx continues its observations of the night sky, it will keep a close watch on 3I Atlas. The comet is expected to reach perihelion, its closest approach to the Sun, in late October, at a distance comparable to that of Mars. Importantly, 3I Atlas poses no threat to Earth. As the comet nears this pivotal point, scientists anticipate that the water ice in its nucleus will sublimate, resulting in a significant increase in its water coma, which will match the existing carbon dioxide coma, along with a more pronounced dust coma and tail than what is currently observed. The SPHEREx team, along with various other spacecraft in NASA's fleet, will be closely monitoring these developments, eager to uncover more insights about this intriguing interstellar visitor. The SPHEREx team has shared a brief report on their findings in the research notes of the American Astronomical Society and plans to publish a more comprehensive paper in the near future. If you're fascinated by space exploration and want to engage in discussions about the latest missions and celestial events, consider joining our space forums. We welcome your thoughts, news tips, or corrections at community@space.com. Stephanie Waldeck, a contributing writer for Space.com, is a self-taught enthusiast of space and aviation. With a passion for all things related to spaceflight and astronomy, she brings a unique perspective to the budding space tourism industry and Earth-based astrotourism. When she's not writing, you can find her watching rocket launches or gazing at the stars, pondering the mysteries of the universe. Discover more about her work at www.stephaniewaldeck.com.